Hello everyone, this video will show how to find coterminal angles. Before we go over some examples, let's have a review on the basic definition for coterminal angles. These angles that we have right here, which are a match, are called coterminal angles. By definition, coterminal angles are two or more angles that have initial and terminal sides in the same position. Meaning, if we take this this line right here as the initial point, if we say 30, the initial and the terminal sides of the angle, so this side right here is the initial, and this is the terminal, because we can go ahead and say that this 30 is from the initial here, it goes to the terminal. This 390 here is that it went one circle, turned around the circle, and then goes back to the terminal. So it started on the same initial, but ended up on the same terminal side. And this 750 degrees here starts from the initial, and it made two turns around the circle back to its terminal position. And this negative 330 here, it starts from the initial, but it went the other way around the circle because it's negative, and it stops on the terminal. So that is what we mean by coterminal angles. So this is the formula for coterminal angles. So if we are given an angle, its coterminal would be, so if we're given an angle theta, its coterminal would either be we add 360 or we subtract 360. So looking at 30 right here, so if we add 360 to 30, that would be 390. 390 plus 360 is 750. Now if we have 30 minus 360, it's going to be negative 330. So to get the coterminal, we just have to either add or subtract 360 from the given angle. Now, what happens if the angle measure is in radian? If the angle measure is in radian, so we see this is in radian right here, we always remember that going counterclockwise direction would be positive and going clockwise direction would be negative. So it's going to be the same thing, but the measure is in radian. So using the previous formula with the degree, we can go ahead and write the formula for coterminal angles if the given angle is radian. So it's just going to be the coterminal would either be we add or subtract 2 pi to the given angle. Okay, so we go over this example right here. Determine the smallest positive angle that is coterminal with negative 40. So we are given a value which is negative 40. And again, we want to get the coterminal for this. So again, based from the review, we can go ahead and determine the coterminal by either adding 360 or subtracting 360. So in this case right here, since we have a negative, we are supposed to add 360 to it. So adding 360 to this, that would be, so negative 40 plus 360, that would come out 320. So this is the smallest positive angle that will be a coterminal of negative 40. Because if you subtract 360 from this, that would come out negative 400. And that's not a positive smallest angle that we wanted. So it's going to be 320. Now let's have another example. In this problem right here, we're supposed to find the smallest positive angle that is coterminal with negative 10 pi over 9. So I go ahead and write this one down here. Since we want the smallest positive, we are going to, again, to get the coterminal, we either add or subtract 2 pi since this is in radian. So since we want a positive, smallest positive angle, so I'm going to add 2 pi to this. Now notice that if we add these two, they don't have the same denominator. So we have to make sure that they have the same denominator. To do that, we're going to multiply 9 over 9 to the second term here. So that this would come out negative 10 pi over 9 plus 2 times 9 is 18 pi over 9. So if you notice, they already have the same denominator. So we can go ahead and add them together. So negative 10 pi plus 18 pi is positive 8 pi, and that is over 9. So this is the smallest positive angle that is coterminal with negative 10 pi over 9. Now let's have another example. In this example, we are given an angle that is negative 864 degrees. Our task is to determine an angle that is coterminal, but should be between 0 and 360. So I'm going to go ahead and write negative 864 down here. To find the coterminal of an angle, we either add or subtract 360. Since we want positive value here that is from 0 to 360, we're adding 360 then. So that is 864 plus 360. Doing the math, that should come out negative 504. And this negative 504 is not within this range, 0 to 360. So we go ahead and keep adding 360. So that would be negative 504 plus 360. So if we do that, that would be negative 144. That is not within the range still. So we keep adding 360. So that's negative 144 plus 360. And the value that we get is 216. And this time around, if you notice, this is within the range of 0 and 360. So the answer to this problem is 216 degrees. Now let's have another example. In this problem right here, we're supposed to determine the coterminal of negative 25 pi over 6, and it should be between 0 to 2 pi. So what are we going to do is we write this down. Since we want a positive coterminal that's between 0 to 2 pi, so we are adding 2 pi to this. So I'm going to add 2 pi to this. Now, if you notice, they don't have the same denominator. So what I would do is I will multiply the second one with 6 over 6 so that their denominators will be even. So this would come out negative 25 pi over 6 plus 12 pi over 6. So this would equal to negative 13 pi over 6. We wanted a positive value that's between 0 to 2 pi. So what are we going to do is we keep adding 2 pi to this. So we're going to take this, that's negative 13 pi over 6 plus 2 pi. And so we are going to multiply this again by 6 over 6. And so this would come out negative 13 pi over 6 plus 12 pi over 6. Subtracting this would come out negative pi over 6. So this is still negative, so we still have to add another 2 pi to this. And I'm going to show the work down here. So the angle that is coterminal with negative 25 pi over 6, that's between 0 and 2 pi, is 11 pi over 6. Now let's have another example. In this example right here, we are given 1,250 degrees and we want the coterminal to lie within our coterminal angle should be greater than 0 but less than 2 pi or 360. So our restriction here is that it should be between 0 to 360. So I go ahead and write this down. Again, to get the coterminal of an angle, we either add or subtract 360. So in this case right here, we want this to go down between 0 to 360. So we're subtracting 360 to this. So this would come out 890 degrees. So this is a coterminal to 1,250, 890. Now, it's not within this restriction. So we go ahead and subtract 360 some more. So that is 890 minus 360. That would give us 530 degrees. Now, this is not within the limit. So we go ahead and subtract 360 again. So 530 minus 360 would give us 170. And notice that 170 is within this interval 0 to 360. So this is the coterminal for this 1,250 angles that's within this range. Although both of these are still coterminal, but we had a restriction that it should be greater than 0, less than 360. Now let's have another example. In this example right here, we're given 31 pi over 5 and we want the coterminal that lies within this limit. The coterminal angle should be greater than 0 but less than 2 pi. So we're going to start writing 31 pi over 5 down here. To get the coterminal angle, we either add or subtract 2 pi. So in this case right here, we are going to subtract 2 pi. Notice that their denominators are not the same. So I'm going to multiply 5 over 5 to the second one. And this would come out. 21 pi is not within the limit because if we change this to degrees, this is 750. So what are we going to do is we subtract this value by 2 pi again. So I'm going to show the work down here. 11 pi over 5 is not within the limit between 0 and 2 pi. So we're going to subtract another 2 pi for this. So the coterminal angle that lies within the interval, coterminal angle is greater than 0, less than 2 pi is pi over 5. If we change this to degree value, this would be 36 degrees. So it's within 0 to 360 degrees. So that is how we determine coterminal angles and how to determine coterminal angles that have restrictions.